So Jamie's flying a kite. String length is 85 meters long, and the angle the string makes is 48 degrees. So we've got a really long string here. Makes an angle of 48 degrees with the ground. So there's our kite. Okay. And we want to know how high it is off the ground. Okay, so this height is a vertical height. It is perpendicular. Okay, that means we have a right triangle, which means we can use trigonometry. So if I want to find the height here, I can set up a trig ratio. Okay, and I know that the height compared to the hypotenuse, 85, is equal to the sine of opposite, that angle is 48, sine of 48 degrees. So I need to work out for sine of 48. So this is where I need my calculator, because I need something to translate that 48 degree angle into a ratio. Okay, so sine of 48 degrees is 7.743. So I'm going to start getting the habit of using 3 decimals. Okay, and I'm also going to make it ratio to 1 because it is a ratio. This is an equivalent fraction, okay, an equivalent proportion. And when I solve for h, I just multiply both sides by 85, and I get a height of 63.2 meters. Okay, that seems about right. 62.3 meters. This ratio should give me an angle about 48 degrees. That looks about right. Okay. So here we have an angle of depression. So we're at the top of the mountain. So we got our mountain here. Okay, at the top of the mountain, the bottom mountain is 38 degrees. So let's make this a little bit more reasonable here. There's our mountain. Okay, and we know that from the horizontal, the angle of depression is measured down. Okay, which if we know our parallel lines, that's actually going to be the same as the angle up the mountain. So we know the distance traveled up the side of the mountain is 300 meters. Okay, so we know that this distance here is going to be 3,000 meters. Okay, so that represents the hypotenuse, and I want to know how high I am, what my elevation is. I'll call it E. Okay, so this angle I'm going to transfer over here because due to parallel lines, and I can calculate, well, opposite hypotenuse. I know that the elevation divided by 3,000 meters is going to give me the ratio of sine of 38 degrees. Okay, so when I calculate sine 38, okay, I get 0.616. Okay, so my elevation compared to that is 0.616 to 1. Okay, and then I can solve for my elevation by multiplying both sides by 3,000, and I get an elevation of 1,846. We can round that to the nearest decimal point. That's going to be 0.0. Okay, so we can set up our right triangle. We have our ratios. We can make equivalent ratios. Remember that these are equivalent ratios. We're making an equivalent ratio, and we're using a proportion to solve this. Okay, and we can use whatever, we can use our proportional equation. We can solve this as a equation by cross multiplying. Any of those are perfectly fine, but make sure you understand, really we're dealing with a proportion here. So there's times when we use our calculator, we need to recognize when we do. Okay, if I have sine 32, well, I want to know the ratio that gives me 32 degrees. Okay, and the opposite hypotenuse ratio. Well, that's not something I know or I can work out. I actually have to use my calculator. So when I use my calculator, okay, I get 0.5299, so I'm going to round that to 30. Again, notice I'm using 3 decimals, and there's actually a reason why I use 3 decimals. But I just want you really to get in the habit of doing it, because when we get into grade 12, this becomes very useful. So tan of 75, again, I need to know the slope that is equal to 75 degrees. Okay, to know the slope, I just don't know these things. I actually need a calculator to translate it for me. So I end up with a slope of 3.732. Okay, so that's my slope. So when I see sine 32 degrees, I can draw a picture, and I know that this ratio, if I can draw 32 degrees accurately, I know that this side, opposite hypotenuse, has that ratio. When I draw 75 degrees, okay, I know that my opposite adjacent, or my slope ratio, is about 3.73 to 1. So when I say my sine x ratio is 0.5, I should also know what that looks like. Okay, 75 degrees, 32 degrees. I can draw a picture of this. If my angle is x, my ratio is 0.5, that means that this is going to be 0.500 to 1, and it's going to give me an angle that looks like that. So I don't know exactly what the angle is. In fact, actually I do, because it's a special angle, but it gives me, at least I have an idea what this should look like. Okay, I need my calculator to work this angle out. This is what it looks like. So if I want to set this up with my calculator, I need to undo my sine calculation. Well, how do I undo sine? I undo sine with an arc sine, or an inverse sine. Okay, and I can actually figure this out. That angle x works out to be, it looks like about 30 degrees. In fact, it's not about 30 degrees. It is exactly 30 degrees. Okay, same thing with when I say that tan x is 3.5. Well, I know that this is a slope of 3.5. This angle, well, it's probably going to be pretty close to 75 degrees. I'm going to guess about 70 degrees. If I want to actually work this out, I need to undo the tan calculation, and I undo tan calculations with arctan. So if I put my output back through my input the other way through the function machine, I go arctan of 3.5, arctan of 3.5, slope of 3.5, it gives me 74.05 degrees. So 74.05 degrees ends up being this angle in here. Okay, and again, the tan ratios gives me the idea what the picture is. The angle also tells me what the picture looks like and gives me an idea. The ratio and the angle are just two different ways to express the same thing. The tan, if we want to go between the two, I need my calculator to go from angle to ratio. I need my calculator to go from ratio to angle. Okay, this is an angle here. Angle, angle. Okay, and that angle is the output of the arctan function. So it's just going from one to the other. I'm just going to go back and forth using either the tan or the arctan depending on the direction I'm going. I think I drew it up here. Right? This is a very important concept. Understand when you use arctan and tan and when you need to use your calculator.